Welcome to chemistry class. Today our topic is isomerism. Isomerism. Isomerism is broadly classified into two types. One is called structural isomerism. Second part is called stereoisomerism. So isomerism is broadly classified into two types. One is called structural isomerism. Second, which is known as stereoisomerism. Under the structural isomerism, we have the following types of isomerism. One is known as chain isomerism. Second, positional isomerism. Positional isomerism. Third one is called metamerism. Metamerism. Ring chain isomerism. Ring chain isomerism. Tautomerism. And last one is called functional isomerism. Okay. How do we remember the types of structural isomers? One is called chain isomerism. So we'll go for one small trick here. It is called C. Position isomerism, it is a P. Metamerism, M. Ring chain isomerism, R. Tautomerism, T. Functional isomerism is a F. So chemistry, physics, maths, revision, test, fail. So my dear students, so this is the small trick to remember the structural isomers. One is called chain isomerism, chemistry, C mean chemistry, position isomer, P for it is a position isomer, isomers, metamerism, M, ring chain isomerism, T, tautomerism, F is a functional isomerism. So in that way, we are going to remember the types of structural isomers for long time. So this is the small trick we made. And come to structural isomerism, it is again two types. It is again two types. First, which is known as, it is called configurational isomerism. Configurational isomerism. Configurational isomerism. Second part, we will call it is a conformational isomerism. Conformational isomerism. See here also, small trick is then CONF is common. Then we'll write according to alphabetical order. It is a I letter, next it is a O letter. So that in that way we can remember easily. Stereoisomerism is again, there is a two types are there. One is called configurational isomerism, conformational isomerism. So these are the types of isomers. So my dear students, again, I will repeat again. Isomerism is broadly classified into two types. One is called structural isomerism. Second part is called stereoisomerism. Under the structural isomerism, we have a chemistry, physics, maths, revision, test, fail. I mean, there is a 6 types of isomerism is possible. And second part, stereoisomerism. Under the stereoisomerism, we have a configurational isomerism, conformational isomerism. So that this again, configurational isomerism. Which one? It is a configurational isomerism. It will come under the stereoisomerism. Configurational isomerism is again classified into two types. One is known as, first one is called geometrical isomerism. It's called geometrical isomerism. Geometrical isomerism. And the second part we'll call it is a optical isomerism. It is called optical isomerism. So this is the very important concept for competitive exam. Under the geometrical isomerism, what are the types of isomers we are going to study? One is called cis and trans. One is called cis and trans. You know that what is the meaning of cis and cis is nothing but same same. Trans mean opposite same. Second, we are going to studying E and Z nomenclature. E and Z system of nomenclature. E is the analog of it is a trans. Z is analog of a cis. And third part is called it is the sin and anti. So what is the meaning of sin? Sin is equal to cis. Anti mean it is opposite. Opposite side. Next one is last one is called fourth one is called exo and it is a end. So it is for IIT advanced. Exo and end. So my dear students, configurational isomerism. Again there is a two types are there. One is called geometrical isomerism. So under geometrical isomerism, we have a types of isomers. One is called cis and trans isomer. E and Z is system of nomenclature. Third part is a sin and anti. We know that cis is equal to is it same side. The similar atoms or groups are present on the same side of the double bond. Trans meaning is similar atoms are present opposite side of the double bond carbon. E is analog of trans is called E. Analog of cis is it is called cis. So generally it is a E and Z system of nomenclature. We will read according to CIP rule. It is called CIP rule. We know that what is the CIP rule? Con, in gold, prolong system of nomenclature. And third part is called sin and anti. Fourth one is called exo and end. Then optical isomerism, it is also known as enantiomerism. It is also known as enantiomerism. Enantiomerism. So this is the complete information about the isomerism. So isomerism broadly classified into two types: structural isomerism, stereoisomerism. Under the structural isomerism, there is a six types of structural isomers we have. One is called chemistry, physics, maths, revision test to fail. Under the stereoisomerism, we have configuration isomerism, conformation isomerism. How do you remember? Say that CONF is the same in both isomers. Then you will write the letter is according to alphabetical order. Then come to configuration isomerism. Again, the following types are the geometrical isomerism. Second part is optical isomerism. So geometrical isomerism again cis and trans, E and Z, system of nomenclature, sin and anti, and fourth one is X and N isomerism. Let us see what is the chain isomerism. Chain isomerism. First we have a chain isomerism. Chain isomerism. So within the bracket we will write Ca. Here it is. Compounds having same molecular formula. So this is the common word we are using, common sentence. Compounds having or compounds have same molecular formula. I will write MF, molecular formula, and molecular weight, but differ, in carbon-carbon linkage. Carbon is a carbon linkage in the molecule. So this is the small definition of chain isomerism. Here, how to remember, how to find out the given isomers are the chain isomers. So, note I will write, note. In both compounds, the size of the parent chain, the size of parent chain must be different, So generally, isomerism, there is a comparison between the two molecules. So in both mean there is a two compounds in that the size of the parent chain must be different. That is the first one. Second one is in both compounds the nature of multiple bonds. I will write MB substituent or functional group. I will write FG. Functional group must be same. You should not change. Must be same. This is the second note. And the third, I will say, in both compounds, the skeleton number, I will write it is a SN. Skeleton number must be different. Must be different. Let us see what is the skeleton number. My dear student, skeleton number is a 2-digit number. Skeleton number is 2-digit number. 2-digit number. Go for example. 24659172. It is a 2-digit number. See, the first digit is represented total number of carbons. The first digit represented total number of carbon atoms in the parent chain. We know that which is the parent chain? The longest carbon chain. The longest carbon chain is called parent chain or skeleton chain also. Parent chain. And the second number is represented number of side chains. So my dear student, you can go for 246591, whatever you want. So the first digit is represented total number of carbons. Second digit is represented number of side chains. Here also total number of carbons in the parent chain. The one is represented number of side chains in the main chain. So the skeleton number is a 2-digit number. The first number is represented total number of carbons in the parent chain. What is the parent chain? So whatever you are going to select the longest chain, that is also called as a parent chain, skeleton chain. And the second digit is represented number of side chains. Let us see first of all. See, I am going to write here hydrocarbon one side, hydrocarbon, number of Ca. What is the Ca, student? Chain isomerism. First, let us see CH4 now. CH4. Total how many chain isomers are possible? No Ca. So with the one carbon atom, we can't write the chain isomers. And CH3, we are going to increase the number of carbon atom. Here also, no Ca is possible. And it is a C3H8. See, it is a 3 2s are 6 and 2 more hydrogen atoms are added. Excess of hydrogen atom is there. It is called alkane. So that here also no Ca. Number of chain isomers are 0. Then it is a C4H. It is there. See that 4 2 is 8 plus 2 hydrogen atom is added. From here onwards, the chain isomerism is possible. So number of chain isomers possibility is the 2. So what is the compound name? It is called N-butane. So there is a one more question. How many minimum number of carbons are required for hydrocarbon to show chain isomerism? What is your answer? So number of carbon atoms are 4. So with the minimum number of carbon 4, we can write chain isomerism, chain isomers. So C4, molecular formula C4H10 exist or have two isomers. Then next one is a C5, 5 2s are 10, 5 2s are 10 and it is a 12. Total number of isomers is equal to, it is a 3. See that. I want to get this number. So that what is the above number is the 2. So multiply with the 2 and it is a minus 1. So that 2 2s are 4, minus 1 is a 3 is the answer. And it is C6, H14 is the 6 2s are 12, 14. See that above number into 2 minus 1. So what is the answer guys here? It is the 5. Similar way, it is a C7, H16 is there. So above number into 2 minus 1. So what is the answer? It is a 5 2 is a 10. It is a 9. 9 isomers are possible. And we will move on to, it is a C8, H18. So how many isomers are possible? So 9 into, it is a minus 1. It is a 17 isomers are possible. So it is C9, H. It is a 18. It is a 9 2 is a 18, 20. So that here it is a 2, it is a plus 1. So answer is 35. So C10, H22. So that 35 and it is a 75. So that this is the way we can remember for a long time. So my dear students, here I have written the type hydrocarbon, name of the hydrocarbon, number of chain isomers. So how many minimum number of carbons are required for alkane to show chain isomerism? So what is your answer? So minimum number of carbons are required of 4. The compound is called butane, it is N-butane. And methane, no Ca. Ethane, there is no Ca. Propane, no Ca. Butane onwards we have a chain isomers is possible. Butane number of isomers are 2. Pentane is 3. Hexane it is a 5. Heptane it is a 9. Octane it is 17. It is a nonane 35. It is a decane 75 is there. So that this is the number of possible isomers of the hydrocarbon. Let us see here. Here butane is has how many total isomers? There is a 2 isomers are possible. What are the 2 isomers here guys? One is called, we will go for a straight chain. So that it is a 1, 2, 3, 4. There is no side chain. What is the skeleton number? How many carbons are there in the parent chain? There is a 4 is there. So it's skeleton number. You can apply here skeleton number. Skeleton number is a 2-digit number. The first number is represented total number of carbons in the parent chain. So that 4 is there. How many side chains are there? It is a 0. This is the skeleton number. What is the one more isomer? Then I will keep 3 carbons in the parent chain. 3 carbon is the parent chain. And 1 carbon must be as a side chain. So what is the numbering is highlighted? 1. It is the 2. It is the 3. Total number of carbons in the parent chain, it is the 3. So number of side chains are 1. See here. So skeleton number is must be difference is there. Is called Ca of each other. So this compound is called N-butane. This is called isobutane. One is called N-butane. It is called isobutane. We got 3 isomers. In the similar way, we will take pentane. What is the pentane formula? 5. 5 2s are 10. Extra 2 more hydrogen atom. It is called pentane. So pentane molecular formula C4H12. So first you try it once. Keep 5 carbons in the parent chain. 1, 2, 3, 4. 1, 2, 3, 4, 5. Numbers 1, 2, 3, 4, 5. What is the skeleton number? The skeleton number is 5. Number of carbons, atoms in the parent chain 5. Number of side chain must be 0. This is called skeleton number. And one more. Now, I will keep 4 carbons in the parent chain. 2, 3, 4. 1 must be as a side chain. What is the skeleton number, students? 1, 2, 3, 4. 4 carbons in the parent chain. Number of side chains are 1. So this is your skeleton number. One more. Now I will keep 3 carbons in the parent chain. 2, 3. Next one is we want 2 carbons as a side chain. What is the numbers? 1, 2. It is the 3. So number of, what is the skeleton number here? Number of carbons in the parent chain 3. Number of side chains are 2. See, number of carbons are 3. Number of side chains, it is a 2. So this is your skeleton number. Skeleton number must be difference is there. It's called chainism. See that it is a 50, it is a 41, it is a 32. Now the compound is, what is the compound name? It is called N-pentane. It is called N-pentane. So this compound is, what is the IUPAC name or common name? See that. This group is called, see, this is called CH3. It is a CH, it is a CH. So this group is called iso group, isopropyl group. So that I will write it is a common name. The common name is always starts with N, iso, neo. That is called common name. IUPAC name is always start with the 2, 3, there is a number will start. It is called iso. Iso. Total how many carbons are there? It is called isopentane. You count total number of carbons. Now this is called common name. C bar N is a common name. What is the IUPAC name? According to rules, it is a second carbon, there is a methyl is there. It is called 2-methyl. It is a butane. 2-methyl butane. Now similar way. Now what is the common name here? The common name, 2 methyl groups are present on the same carbon atom. Then we will allot it is called neo. How many total number of carbons are there? 5 carbons are there. It is called neopentane. What is the IUPAC name? According to rules, second carbon, at the second carbon there is a 2 methyls are there. It is called 2, 2 dimethyl. 2, 2 dimethyl. It is a propane. So no, there is no gap here. So this is the one. In the similar way, this is all we have written open chain compounds. If I will take the cyclic ring, for example, cyclopentane I have taken, or you can take a cyclopentane. See that it is not open chain, it is one of the closed chain. What is the compound name, students? It is called cyclopentane. It is cyclopentane. So once you try it, how many carbons are there in the parent chain? 1, 2, 3, 4, 5 is there. So we want skeleton number must be different. The size of the parent chain must be different. 5 carbons in the parent chain. Now what I am going to do is, I will keep 4 carbons in the parent chain. 4 carbons in the parent chain. And 1 carbon must be as a side chain. So allot the numbering 1, 2, 3, 4. So what is the IUPAC name? It is called 1-methyl. 1-methyl. It is a cyclobutane. It is cyclobutane. Again, what is the one more? Again, I will decrease the size of the parent chain. I will decrease the size of parent chain. See, this is the first number. Second number will be, now I will keep 3 carbons in the parent chain. We want still how many carbons? 2 carbons we require. So that I will write like this. So what is the IUPAC name of this compound? It is the numbering is allotted 1, 2, 3. Now it is called 1 ethyl. It is called propane. 1 ethyl cyclopropane. 1 ethyl cyclopropane. Cyclopropane. What is the third one, student? Is there any other possible isomers? Yes, one more possibility is there. I will keep 3 carbons in the parent chain, 2 carbons as a side chain. So numbering allotted 1, 2, 3. This is called 1 comma 1. It is a dimethane. Dimethane. Cyclopropane it is. Cyclopropane. What is the fourth one? I am going to change the location of the substituent. Now 1, 2, it is a 3. So 1 comma 2, it is a dimethyl cyclopropane. Cyclopropane. And finally you write down what is the skeleton number. It is either cyclopentane have all these isomers. Cyclopentane have all these isomers. We will see what is the relation. What is the skeleton number, students here? Total number of carbons in the parent chain 4. Number of side chains will be 1. What is the skeleton number for this compound? It is the number of carbons in the parent chain 3. Number of side chain is 1 it is. Here skeleton number. Number of carbons in the parent chain 3. How many side chains are there? 2 are there. It is a 3, 2. Here number of carbons 3. Number of side chains are 2 is there. See that? What is the relation? This one compound and second compound. What is the relation is there? The skeleton number is there. Must be difference is there. The skeleton number is remains difference. Different is called chain isomer. So second and third one is, it is a 3, 1, it is a 3, 2. So skeleton number is different. It is called chain isomers. 3, 2 and 3, 2 both are same is there. Now these are called positional isomers. Positional isomers.